Good afternoon. Our next presentation is from Mr. Etienne Poeder, and the name of the presentation is Software Testing, the Solution for Better Quality.
Hello, my name is Etienne Poeder, and I'm going to talk about software testing, the solution for better quality. During this presentation, I will show you why we, as professional testers, believe that testing, structured testing, is the solution for better quality. When we were preparing for this presentation, we noticed how well the theme is fitting our work field. To connect is to establish communication between objects. And this is what we do as professional tester. We connect the business with the technical side of the business. We connect test objects when we test objects, software products, but test the dependencies between them as well. To explore is to examine a specific object. And this is what we do. We examine. We examine the capabilities of software, we examine the requirements, and develop. To develop is to create. We create as testers when we give insight into the quality of a specific system. When we offer the customer the ability to improve his software product. This is where we create. We will go through this presentation. We have defined a problem statement, and based on this problem statement, I will show you why we believe that software testing is the solution for better quality. The problem statement is no testing or non-structured testing leads to failures. This is a pretty bold statement, and I will show you that the consequences are even bolder when you're not testing or not testing structured. In 2014, recalling 1.9 million hybrid cars, of which 713,000 were in North America, thanks to a nasty software issue. 1.9 million hybrid cars. I don't know how many cars there here in Suriname. Does anyone know how many cars there are in Suriname? How many? 100,000? Okay, imagine 1.9 million hybrid cars. That's a lot of money. 2014, it appears that a computer glitch has led to approximately 2.3 million in tax reversal errors. $2.3 million. Imagine your company not being able to access $2.3 million for 2, 3, 4 weeks or even months because you need to trace where the error came from, if you even find it. Between 85 and 87 bugs in software powering the Therac 25 medical radiation therapy have caused a number of patients to receive up to 100 times the intended radiation dose. 3 patients died as a direct result. This is how serious a bug can be. This is not a bug on your Android phone with an application. This has cost many people their lives, okay? What is non-structured testing? Non-structured testing is something we do every day. Whether you buy an apple, not a device, an apple actually eating, or you buy a pair of shoes or a pair of glasses, and you need to convince yourself of the quality of the product. And that's easy, because you know what you're looking for in an apple. You know what you're looking for in a pair of glasses. So we do this every day. If you want to know what structured testing is, you need to look first at what quality is. Because quality is the proven totality of documented features and capabilities of a product or service to satisfy the needs of a customer. This is a mouthful, but what it actually says is you need to prove the functionality of your product or service. And you need to fulfill the needs of the customer. Those two characteristics are very important for quality. Structured testing. What is structured testing? Provide objective and reliable insight to the quality and risks of a product or service. So with unstructured testing, non-structured testing, you only need to convince yourself. But if you are testing in a structured way, you need to convince the customer. And no professional tester is convinced of the quality of a product and the risk unless he has tested it in a structured way. So you need to test structured so you can provide objective and reliable test results. That is very important because if one day you present the result that 80 out of 100 test cases have been approved, and the week after you rerun the same test cases, and it's less or more, you don't have a reliable test result, or maybe something changed in the conditions. But it's important that you have reliable test results, because that's the only way you can prove what the software product is going to do in a production environment. Does anyone play golf here? Golf? No one? Okay, I don't like golf at all, so I'm safe. But there's one interesting point about a golf ball. Most people see only the outside of a golf ball. Until I Googled some and found out that it is built of different layers. A golf ball is built of different layers. 1, 2, 3, 4. And this is how most people perceive testing. When people think about testing, they only think about, oh, okay, you are identifying bugs. Yes and no. It's not only identifying bugs. I must admit, we do this a lot, most of the time. But it is important to not only identify bugs, but to work with a specific structure. For instance, we work with test scenarios. A test scenario might be storing a specific file on a specific server at some point in time. This is a scenario, but this scenario cannot work unless I have defined the test execution steps. What are the test execution steps? First, you need to log on to the system, you need to click on the application, and then you need to click on this, this, and this, and this. So these are the steps in a specific order. And it's very important because you don't want to execute a test case in a different way that it was intended to be executed. Otherwise, you might get different results. But there's no way you can define the test execution steps if you haven't studied or assessed the test basis. What is the test basis? The test basis is a collection of technical documentation, all the recorded documentation that gives you an idea of the overview of the functionality, of the dependencies of the functionality. So this is your test basis. And there's no way you can have a test basis if you don't have requirements. What are requirements? Requirements are actually the first phase of a software product. This is where people start to think about what they actually desire from a specific system. Requirements are developed in, it might as well be your CEO waking up 2 o'clock in the morning, honey, we need a better system. And she's like, yeah, sure, honey. But that requirement was born right there. And then he starts to, this same CEO starts to mess up people at his job, telling, we need to have a better system. And everybody's, okay, we need to have a better system. And then when he walks out the room, what does he actually mean? And then people start to think about what the requirements are. A better system. Well, we noticed that this system has crashed for 2 times in a row in the last week. Or maybe is it because I was locked out of the system after 3 times trying to log on successfully. So this is where people start to think about the requirements. And this is the first phase where you actually, with defining the requirements in a smart way, to actually create a test basis, a technical design, a functional design. So this is, in this phase, necessary prerequisite for testers to test a specific software. for a tester, in order to effectively choose a test strategy, he needs to know how the software was developed. There are several software development life cycles, and I will cover two of them. And one of them is the V model. This is the most boring part of the presentation, I'm sorry. But the V model, I must mention it because the V model is being used by a lot of companies. Some of them in their benefit, some of them they are really being messed up by the same model. But what you need to know about the V model is it works with different stages. And one stage will not move on to the next stage unless this has been completed. So you will not have, you will not start with the design unless you have the requirements. And the outcomes of these stages will be used to test. For instance, these requirements where I was talking about, we need a better system. This will be used, it needs to be smarter than that, but eventually it will be used by your end users because you're developing software for an end user. So while you're testing the database, while you're testing the interface, you can do all these technicalities, but in the end you need to know whether this system is meeting the fulfillment of the end user. So this is very important for the tester to know, okay, we're working with a V model, so I need to wait until the requirements are finished. So I need to wait when the technical design is finished. So this will help the tester to choose a fitting test strategy. Another development life cycle is an agile method. This is, unlike the V model, already starting without a test basis. There's no documentation ready. We only have a few requirements. And with those few requirements, we will start exploring. There you go, the theme of this summit. Examining, what do we have? What can we work with? And with this little bit of information, they start to design. And with the small design, the small portion they have designed, they actually start coding this design. And with this small portion, this unit of software, the tester will start actually testing it. And the good thing of an agile method is all the stakeholders, the business, the technical side, the maintenance, they're all represented in this project group. So they work in short cycles, 2, 3, 4 weeks, and they produce small portions of software. And if this is approved, they will actually deploy it to production. And after this cycle, they will move on in exactly the same way with another portion. So you have short cycles developing chunks of software and deploy them to production. Unlike the V model, where you actually work for months on a design, if something is being messed up here, you only lose like 2 weeks, or 3 weeks, or 4 weeks. Test preparation. What do you need to do as a tester to prepare your test? You have to set up the groundwork. Test bases, we have covered that. This is the documentation, which gives you an overview of the functionality, the requirements, designs, code. And let me add this to it. Testing is not only clickety-click. Testing is even reading a document, examine the document, and you can actually find defects in a document. Defects is not only about software, because if you identify a defect in a design, I think this company will be very happy with you as a professional tester, because you have prevented this defect to be deployed in the software. And this costs less money than finding it after 2, 3, 4 months. So, the test basis. The test technique. Depending on the quality of the test basis, depending on the completeness of the test basis, you will determine what the test technique will be. For instance, if you get only flowcharts, you need to find a technique that fits the flowcharts to generate test cases. If you get only tables, you need to find a fitting test technique that will give you the ability to effectively generate test cases. What are test cases? Steps, conditions, or variables to predict abnormal or normal system behavior in a controlled environment. You need to, like I discussed earlier, if you have a test execution, you need to define the steps specifically in a specific order. If you're not doing this, you will give the executor the possibility to interpret the test steps. And that is something you don't want. You want to be in control when you test something. Because if you identify a defect, you need to reproduce it. Because if you cannot reproduce a defect, then the programmer will not have any attention for you. You need to be able to show him what is actually happening. And to improve, to make sure that you are actually reproducing it, you need to take exactly the same steps. This part is very important for test cases. A controlled environment. You need to have a controlled environment. But what you can do is to make your test environment a controlled environment as much as possible similar to your production environment. Because the environment where the software is being developed is not identical to the test environment. Why is that? Because a development environment is meeting the standards of a developer. He needs to have a fast machine, he needs to restore it, he needs to have the tools installed. All this specific development environment is unlike the tester environment because you are testing the end user's perspective. So the end user isn't working with a fast machine with all the tools installed. And it needs to be controlled. You don't want to access the test environment one day and not being able to access it the other day. You don't want to use test data one day and the next day the test data is completely gone. Test strategy and context. It's very important to have a test strategy to define what you actually are going to do during the test. A test strategy is being fed by multiple factors. One of them are risks. Well, you cannot start thinking about risk while you are testing. You need to think about and identify your risks before you start testing. And you can do that by executing a risk analysis. By executing a risk analysis, you have an overview of the risks, and having an overview of the risks, giving you the ability to plan accordingly to that risk. The business is feeding the test strategy as well, because the business might say after 2 weeks, hey, I think this priority on this requirement is not high enough. I think we really need to increase the priority on this specific requirement. And I want to ditch this other requirement. So this will feed you and gives you the ability to think about, okay, what should I do with my test objects if I'm testing them? And the business comes up with an idea to just increase the specific requirements on the test object. So you need to think about what you are going to do if things are not according to your plan. And in your plan, you have all the activities defined, your resources, your the order in what you want to execute the test objects, the planning, the risks, the test strategies in there as well. And all these things give you, they give you and the customer the overview of how you want to execute your test project. And of course, in the end, you want to meet the project objective. Test management. What is test management? You should, if you want to think about what test management actually is, you should not expect less from a test manager as what you would expect from a project manager. The test manager still has to report to a project manager, But just like a project manager, a test manager needs to know what the insights of the test project, the activities in here, where you have planned the scope, you have defined the scope, the test strategy, the resources, the dependencies, the risks. You need to know exactly what is happening and what is going to happen so you can plan accordingly. The test project planning is very important. Many people, or not many people, I think most of the management would like to receive a planning that fits their expectation. Of course, test managers want to offer the same, but it's better to present a realistic planning. It's better to make people scared with realistic planning than making them happy, and after 2 months, well, we're not going to make it, and this, and then. So define a realistic planning. This works far more better than just making something up. Test execution. If you have your test plan defined, it has been approved by the company, you have a project planning that has been approved by the business, you can start execute your test cases. And you do this, of course, according to that plan. Test control. When you have, if you are being confronted with, for instance, a specific test environment that is not ready before time, you could choose to switch the sequence of the test objects that you are testing. And that is very important because you have already thought about that when you were defining your test strategy. Knowing, for instance, we have a resource problem. Okay, if you know that you have a resource problem, you should already think about what am I going to do if I'm run out of resources. So you're not stuck immediately. And in test control, you will be able to replan. You will be able to maybe you need to hire a lot of testers at some point because the priority of the business has been increased. Or you have to let go subcontractors, testers, because the test environment will not be ready in another 2 months. You need to prioritize, and this prioritizing needs to be aligned with the business. Maybe you need to descope. This is what you do in test project management. If you have to sum up what testing is, it is about verification and validation. Verification is where you actually prove what the functionality is. And validation is where you try to fulfill the needs of the customer. If, for example, I would buy a bicycle and the store tells me, well, I've tested it on asphalt, I've tested it in the desert, in the water. Well, okay, I'm convinced. Okay, I will buy that bike. But if this bicycle appears to be this size, I have a problem. I'm not very tall, but in this example, I'm very tall. But then you have a bicycle that is not going to be able to be used by me. And he actually didn't lie about testing it, the bicycle. But what he did not mention is, he didn't validate it according to my fulfillment. So software is not perfect or good if you don't have any, if you didn't identify any defects in it. Because not identifying defects might result in the fact that the end user will not be able to use it. So quality is not only about not being able to find defects, it's about fulfilling the needs of the customer as well. You can see it here, verification, does it work? That's a functionality. And validation, does it fulfill the needs of the customer? And this is very important. To fulfill the needs of the customer, you need to align with the business. If you're not aligning with the business, you will only know what has been recorded. You will only know what's in the technical documentation, in the functional documentation. But you will not be able to sit in the chair of the end user and think about how he would be using the software. This is very important. And this complete, the sum of the does it work and the does it fulfill the needs of the customer is your business value. How can you determine business value? there's a model, and this is the value creation model of ITIL version 3. And this is a model to give you an idea how this works. In here you have the warranty, this is the functionality part. And here you have the utility, that's fulfilling the needs of the customer. They have mentioned here or, that means that one of the two branches, if that is true, you can proceed. So you have proven the fit for purpose. One of them could be, does it support the performance? If it does support the performance, you have already a true. Or another one could be, does it take away any constraints in the software? If you take a look at the warranty part of it, they're very strict. They say it needs to be available, the system. It needs to have enough capacity. It needs to be secure. And it needs to be continually available. Those four are important. If you take out one of them, the outcome will be false and you will not be able to prove that you have business value. Why is that? For instance, if I have software that's continually available, you can access it and it has enough capacity, but it isn't secure, you have a problem. You might have a problem with this guy here, right? Security. You don't want to have trouble with security people of a company. So, for instance, if you have a secure software, it's continually available, you can access it, but it hasn't enough capacity, did I mention that? Then you still have a problem because you will not be able to offer the service you have intended with your design. So the outcome of both of these will give you fit for use. Is it actually working? And fit for purpose. Does it fulfill the needs of the customer? And that is business value. We have covered until now the test basis. The test basis is the overview of the functionality, the recorded overview of the functionality, insight into the functionality, the importance of a risk analysis, because knowing the risks will enable you to plan accordingly to that risk. The importance of a test strategy, giving insight to the customer, how you are going to respond when things are happening that you didn't expect. The test plan, an overview of all the activities that have to be executed in a specific order, according to a timeline. And your test preparation. How are you going to define your test cases based on a software lifecycle, choosing your test technique. And this is important to actually start, ik heb u gezien, your test execution. Why is this part so important? Why am I making such a big deal out of it? Because before you engage into identifying what the business value of software is, you need to have tested in a structured way. There's no need for me to fulfill the needs of the customer if the system doesn't work. And in order to convince the customer that the system is working, I need to have proven, according to scientific methods, that the software is actually working. There is a connection with the database. You can send XML messages over a specific interface. You are able to continuously access that specific system, and if I'm not authorized, you cannot access that system. You need to prove all these functionalities, features, before you engage in fulfilling the needs of the customer. That is why it is important in an early stage to incorporate the end users. Because although your system might not be fully ready, you can ask the opinion of the end user. So if you have engaged in functional tests, technical tests, you have incorporated the end user in this process as well in an early stage, then you can engage in business value. And this is what a customer wants to know. Because I can test a lot of test cases and hand over a report with, okay, 80 out of 100. I've tested 80 out of 100, and according to me, it was a good test result. No, he wants to know, is this software product going to be used by my end users? Is this software product going to help me to increase my productivity? Is this software supporting my security? This is what business value is. So if you think about business value, of course think of Misabi, test management. But if you think about business value, think about having tested it in a structured way. I didn't mention the fact that I work for Misabi Test Management, since this is a non-commercial presentation. Are there any questions? Oh, you didn't hear me? Oh, okay. Sir, I work for Misabi Test Management, but I'm not allowed to say that because this is a non-commercial presentation. I know you. Oh, okay. Are there any questions? Yes. Yes.
Isn't there a big difference between what they want and what they need?
Yes. Yes. There's a very big difference between what an end user wants and what the company wants to pay for. But still, they have an opinion. And that opinion might, at sometimes, give the end user the idea that they can just determine anything they want. But on the other hand, they will give you insight in what they expect. Because although they might have expectations that have not been developed in the software, it still gives you an idea what they want. Because if they have expected features and functionality that you're not able to prove, you have a problem. Why do you have a problem if you wait until the end user acceptance test? Because then you have already finalized the requirement stage, the technical stage, the functional stage, the integration between the systems, and the end user acceptance test is in the end. So there's no time left. The CEO is already complaining. You have 2 kids and they have to be fed. So you have a lot of problems you don't want. You want to avoid that. So start incorporate the end user in the beginning. Be realistic about it. If yeah, but I want this software to be pink and I want this. Okay, I hear what you say. I'm taking note of it. But if what the end user wants does not meet the standards of the recorded documentation, it simply is not going to be there. So you have a valid point there. There is a gap between what the end user wants and what the company actually wants to pay for. It's like what kids want and what their parents want to pay for. Almost it's the same. Go ahead, sir. In which stage
of the testing process?
Yeah.
Yeah. In which stage of the testing process? Yeah, we can put beta testing, because a lot of companies, they give beta software for users to test, to find bugs, etc.
Well, actually, I mentioned it in trying to answer the question of this Mr. here. You can incorporate the end users in a beta testing. Just don't call it an end user test. Because if you call it an end user test, he's going to sit there, clickety-click, and then his final report will be, well, I'm not accepting this. I'm not going to work with this. This is not according to my standards, blah, blah, blah. But if you call it a beta testing, you will give him the ability to work in an early stage, give you an idea of how he's experiencing the software, and some of these points might be valid to hand over to the technical part of it, the development. Sorry? The end part? No, I suggest, my recommendation would be, if you have communication with the end user, of course you need to communicate with the business, but try to do this as soon as possible. There's no need to incorporate the end user when you don't have an interface and you need to access a database, because he's not going to use the software without an interface. But as soon as you have a premature version which gives you an idea of the system, you can already incorporate him. But just don't call it an end user test, because this will give him the mandate to actually say, well, I'm not going to use this. And he will carry this perception all the way until he actually is going to execute the end user test, and he will say the same.
Sorry.
One method, that's the beta testing. But what are other methods that you use to involve end users?
I'm not calling in specific methods, but the way you want to do it is to make sure that the end user really realizes that this specific test is not part of the actual formal test. And you can, depending on what the stages of the software, the maturity of the software, you can have him executed some test scenarios. So I would not say it's a specific technique. Of course, you can do interviews, you can do a presentation, an interactive presentation, things like that. But I don't know a specific method to say, well, okay, you are using SAP, so you need to use for a premature or a premature end user acceptance test, you need to use this. No, I don't have that. Any other questions? Okay, then I thank you for your patience. I thank you for your time. This is my thank you. I would like to thank the Misabi team, 2 colleagues, and the 3rd one. They have helped me a lot preparing this presentation, so give them a hand as well. And you should not take a look at this because it is a non-commercial presentation. Please do not take a look at it. Thank you very much.